Mr. Gordon, Stemmers Run math teacher, back with you for another week of pre-algebra learning on BCPS-TV. These lessons are for the week of May 11th, and the first lesson we're going to work with circles. All right, we have two lesson objectives for lesson one. The first is for students to use a formula to find the circumference of a circle, and with the second objective, students will use a formula to find the area of a circle. As we think about circles, we've got a lot of key vocabulary. So circumference, our circumference is our distance around a circle. So when I think of the distance around something, I usually think of perimeter. So you can think of the circumference as the perimeter of a circle. It just uses a different vocabulary word. The diameter. The diameter is a line segment that passes through the center of a circle and has endpoints on the circle. So an easy way to think of that, it goes all the way through the center of the circle. The area. The area is the number of square units needed to cover a surface. So think about it as the space inside the circle. The center is pretty self-explanatory. It's the point inside the circle, and it's the same distance from all points on the circle. The radius. The radius is a line segment with one endpoint at the center of the circle and the other endpoint, on the circle. So it goes halfway through the circle. Here's a nice diagram laying everything out. You can see we have our center, we have our diameter as our blue line, our radius is our red line, and the last thing you need to carry with you in terms of the vocabulary is this understanding that the diameter is twice the radius. Very important when we get to calculating the circumference of a circle. All right, so now we're going to look at how some of these vocab words are related and the relationship between specifically the circumference of a circle and its diameter. All right, so this goes for any circle, any size circle you could think of. Circles on your paper, circles out in nature, big circles, small circles, any circle that you can come up with. There's going to be a connection where the ratio of the circumference to the diameter, meaning C divided by D, is the same for all circles. This ratio is called pi, spelled P-I, and you can approximate it as 3 1400 or as 22/7. So whenever you're doing a mathematical definition, it's important you reread it and try to unpack that definition. So let's look at it. So the ratio. All right, so last lesson we talked about a ratio is simply a fraction in this case. So the ratio of the circumference, which is our distance around the circle, to the diameter, which is our distance through the circle, is always the same for any circle. So in essence, if I take this green circle and I go all the way around and I come up with that number, and then I divide it by the distance here, I always get the same number, which is approximately 3 1400. Any of these circles, the distance around divided by its distance across always produces a number approximately 3 1400. Mathematically, this number is called pi. Pi is one of the most fascinating concepts in mathematics. What makes the number so fascinating and intriguing to mathematicians is it's a non-repeating, non-terminating decimal. This means it never ends and it never follows a pattern, which makes it what we call an irrational number. Therefore, everything we do with pi is truly a approximation because the decimal never ends and it never repeats. Mathematicians have calculated out to thousands and thousands and thousands of decimal places. What you see right here is just a sample of the decimal taken out to several decimal places. But this number has been studied by mathematicians for centuries, and it will be continued to be studied moving forward. Because this ratio, C divided by D equaling pi, works for any circle, we can use this to develop an equation to find the circumference of any circle in terms of its diameter. All right, so in order to do this, if we think about the circumference divided by the diameter is pi, then we can isolate our circumference by multiplying both sides by d. If we simplify the equation, we get the formula c, which is circumference, equals pi times its diameter. Remember, the diameter of a circle is always twice the radius. So if the radius is 5, the diameter is 10. Therefore, if we use a substitution property, we can develop a second formula in terms of the radius. So the first one we developed is in terms of our diameter, and we can develop another one in terms of our radius. Here's how we do it. If circumference equals pi times diameter, and diameter is twice the radius, or 2r, then we can substitute d with 2r, giving us a new formula of circumference equals 2 times pi times the radius. Therefore, we end up with c equals pi times diameter, and c equals 2 pi r as our two formulas we can use to find the circumference or the distance around a circle. All right, so let's apply these formulas into our first example. So in example 1, we have to find the circumference to the nearest hundredth. We're going to use 3 14/100ths for pi. All right, so the first thing I got to look at is that I have to round my decimal answer. And I need to take a look and see if I'm given a diameter or a radius. So as I look at that dotted line, I see that that is a diameter. Therefore, I'm going to use c equals pi times diameter. So the first thing I'm going to do is I'm going to substitute in what I know. I know my diameter is 11. I'm going to use 3 14/100ths for pi. I'm going to use my calculator to multiply these, and I'm going to get c is about 34 54/100ths. If you notice, my equal sign is now these two little squiggly lines. That's because what I have is an approximation. If you recall, 3 14/100ths is just an approximation for pi. It is not an exact value. That gives me a final answer then that the circumference of the circle is about 34 54/100ths centimeters. All right, time to show what you know. I'm going to give you 1 minute to find the circumference of this circle. All right, so once again, we're given a diameter. So we're going to use the same formula, c equals pi d. We're going to sub in 20 for our diameter. We're going to sub in 3 14/100ths for pi, giving us about 62 8/10. Therefore, for this problem, the circumference of the circle is about 62 8/10 yards. Okay, so for example 2, once again, we're asked to find the circumference to the nearest hundredth. However, if you take a look at this example, we are not given the diameter, we are given a radius. So I'm now going to use a different formula. So now I'm going to switch from C equals pi times D to C equals 2 pi r. I'm going to sub in 14 for my radius. I'm going to sub in 3 1400ths for pi. And now I'm going to use my calculator to get an answer of 87 9200ths. So for this example, the circumference of the circle is about 87 9200ths feet. Time for you to show what you know. I'm going to give you 1 minute to try and determine the circumference of this circle. All right, so once again, we're given a radius. This time our radius is 12 millimeters. So again, I'm going to use C equals 2 pi r. We're going to sub in 12 for the radius, 3 1400ths for pi. We're going to use our calculator. We're going to get that the circumference is about 75 3600ths. So in terms of our units, we'd say the circumference of the circle is about 75 3600ths millimeters. So now that we looked at circumference, we're going to start our transition to area. So using some prior knowledge, hopefully activating some prior knowledge from Math 6 and some of the elementary school years, you remember that a square and rectangle have a formula, area equals length times width, and triangle is area equals 1/2 base times height. The area of a circle is going to look a little bit different. And again, it's going to use this concept of pi. So the area of a circle is equal to pi times the radius squared. All right, very important to remember, I've been stressing units. We're now going to be in square units for our answers because we're literally thinking how many squares can fit inside of this circle. The area formula of a circle does not allow for diameter. Unlike circumference, where we could use 2 formulas, area is only one, and that's area equals pi times radius squared. All right, so let's apply this to our next example. So in this case, we have a biscuit recipe that calls for dough to be rolled out and circles to be cut from the dough. The biscuit cutter has a radius, I'm going to highlight that, of 4 centimeters. Find the area of the top of the biscuit once it is cut. Use 3 1400ths for pi, but this time we're going to round to the nearest tenth. All right, so in this case, I'm going to use area equals pi r squared. I'm going to sub in my radius of 4. And I'm going to remember that 4 squared is 16. This is a very common mistake when we're dealing with the area formula. A lot of kids think that's 8, but that's 4 times 4, which is 16. Then we're going to sub in 3 1400ths for pi, and we're going to get an area of about 50 2400ths. Now, we're going to round to the nearest tenth. That's 1 decimal place. So in this case, the area of the circle is about 50 2/10 centimeters squared when we round it to the nearest tenth. All right, time for you to give it a shot. So we're going to find the area of the circle to the nearest tenth. Now, because my example didn't have this in it, I want you to pay special attention to the fact that you're given a diameter. The formula calls for the radius. So remember, this is twice the radius. I'll give you about a minute. See if you can use A equals pi r squared to find the area of this circle. Okay, so using area equals pi r squared, hopefully you thought to use 10 for your radius, not 20, that's a diameter. We're going to sub 3 1400ths in for pi. We're going to multiply by 100. I could use my calculator. I could remember multiplying by 100 moves the decimal point 2 places right, which gives me an area of about 314. That means the area of this circle is about 314 yards squared. Though the direction said to round, my answer does not need to be rounded. Okay, that wraps up lesson 1 for the week of May 11th. So now we're going to head to lesson 2, which is going to be area of composite figures. In this lesson, you'll use area formulas for simple geometric figures to find the area of a composite figure. We have one key vocab term for this lesson, and that's the idea of a composite figure. In order to break this definition down, we brought back in our resident vocab expert, Lila. So Lila, a composite figure is a figure made up of simple geometric shapes. What stands out to you in that definition?
Simple geometric shapes.
And the word simple, what does that mean to you in this case?
Squares, triangles, and rectangles.
Good. And what about the word shapes? What does that tell you?
More than one.
Excellent. And she's exactly right. A composite figure is going to be made up of more than one shape. We have several common area formulas you have probably seen before. These are for what we call our simple figures. So Lila mentioned the triangle. We mentioned the square. We mentioned the rectangle. Parallelogram could also be in a composite figure, and a trapezoid. Very important that you refer back to these formulas anytime they show up in any of the composite figures. So here's our first example with composite figures. And the first thing I would ask you, if you were trying to do this problem, is I'd ask you, what two simple figures do you see in this composite figure? Hopefully you'd be able to identify that there's a triangle and a rectangle in this composite figure. From there, I might ask you, what two formulas do you need to solve this? And hopefully you can recall a triangle is area equals a half base times height, and rectangle equals length times width. So what I like to do now is I like to bring each of those simple figures out and kind of separate them and start to find the area of each. So for my rectangle, I have a length of 14 centimeters. I have a width of 12 centimeters. For my triangle, I have a base of 8 centimeters and a height of 12 centimeters. Then I'm going to find the area of each. So in order to do this, for the rectangle, I would do length times width and get an area of 168 square centimeters. For the triangle, I would do a half base times height and get 48 square centimeters. So therefore, the entire composite figure, if I add those two totals, has an area of 216 centimeters squared. What's interesting about this composite figure, we broke it down as a rectangle and a triangle. It in itself is actually also a trapezoid. So we could have used our trapezoid formula as well. All right, your turn to show what you know. So you're going to find the area of this composite figure below. It looks like we have a rectangle and a triangle, and I want you to pay special attention to the fact that the height of this entire triangle is missing a unit of measure right here. That's your hint. I'll give you about a minute. See how far you could get through the process of finding this area. Okay, let's see how you did. So figure one, our rectangle, had a length of 10 feet, a width of 4 feet, giving us an area of 40 feet. Our triangle had a base of 6 feet and actually a height of 7 feet. I had to use my 4 feet over here, add it to my 3 feet to get the total height. That gives me an area of 21 feet squared. When I add those two together, the entire composite figure had an area of 61 feet squared. All right, that's all I got for you for this week. Hope you've learned a little something about circles and composite figures. Until next time, be good and be safe.